Now we are going to start the topic properties of determinant. The first property is this, that is, if the rows or columns of a determinant are interchanged, then the value of the determinant so obtained remains unchanged. That is, if I take a matrix, suppose I take a matrix A and then I take the determinant, or I take the transpose of this matrix, I take the determinant, both are always same. For example, if I take a determinant of 5, 1, minus 1, 2, 6, 0, 3, 4, 2. In the last video, I got the answer 66. Now you can do it on your own. If I take the transpose, that means I make 5, 1, minus 1. I make the rows, the columns 2, 6, 0 and 3, 4, 2. I will get the same value. That it means by the first point. Now the second point is that, the second point, let us see the second point. The second point is, if any adjacent rows or two adjacent columns are interchanged, the value of the determinant so obtained is negative of the original determinant. I'll make you understand this with the help of this very same example. This is the second point. I have the value 5, 1, minus 1, 2, 6, 0, 3, 4, 2. Now this value of this I got as 66. Now what I do is that I change this, I interchange the row or the column. Wait a minute. I interchange the row or the column. That is, I am interchanging these two rows. For the first and the second row, I'm interchanging the rows. 2, 6, 0, 5, 1, minus 1, 3, 4, 2. Then I'll get minus 66. Similarly, from the original one, if I interchange the column, that is, if I interchange this and I interchange this, that is 1, 6, 4, 5, 2, 3, minus 1, 0, 2. I'll again get minus 66. This was the second example. Now let us see the third. That is, if the elements of any row or any column is the sum or the difference of two or more elements, then the determinant can be expressed as the sum or difference of two or more determinants. That means, suppose I write this third one. I have, let me take some more space. For this, suppose I have A11 plus minus B11, and then I have A12 plus B12, A13 plus minus B13, and then A21, sorry, this is A21, A22, A23, this is 1. Let me make it clear. This is 1. Then this is A31, A32, A33. Then this can be written as, A11, A12, A13, A21, A22, A23, A31, A32, A33, plus or minus, whatever the case may be, B11, B12, B13, A21, A22, A23, A31, A32, A33. This is the third case. Now we will see the fourth case. The fourth case is, if any two rows of a column of a determinant are identical, then the value of the determinant so obtained is 0. This is the fourth one. I'm talking about this fourth one right now. This one. This fourth one I'm talking about. If any two rows or columns of a determinant are identical, then the value of the determinant is 0. Let us see below. Let us see below. Let us see below. Now, I said, this is the fourth one. Suppose I have 5, 6, 7, 8, 9, 10, and again I have 5, 6, 7. Since any two columns are same, so the answer is straight 0, or any two rows. Suppose I write 5, 8, 5, 696 and 585. Again the two rows are same, this and this row are same, therefore this is 0. Here the columns were same, so again this was 0. This was the fourth property. Let us now see the next property, the fifth one. The fifth one says that if the element of a row or a column or a column of a determinant are multiplied by the same number k, then the value of the determinant so obtained is k times the value of the original determinant. Now let's see this. Let's see this here. Suppose I take the example for 5 is I take the same example. Suppose I take 5, 1 minus 1, 2, 6, 0 and 3, 4, 2. 3, 4, 2 and the value I got is 66. Suppose I do is that I multiply the first row with some number say 2. So 2 into 5, 2 into 1, 2 into minus 1. Let us put the brackets here so that you don't consider as decimals. Now it is 260,342. Now this is going to become 2 times 66, that is 132. This is what is going to, what it is saying. The fifth point is saying this. Now let me tell you one thing. In determinant, suppose if this was a matrix, suppose this was the matrix 5 1 minus 1 2 6 0 3 4 2. If I had multiplied with some number k, this 2a, then all the elements here would have been multiplied. This would have been 10, this had been 2 minus 2 4 12 0 6 8 4. But in case of determinant, only one row can be multiplied or one column can be multiplied, and the determinant value will be this. Now see, here is a very good property. Suppose A is n cross n matrix. Now I multiply A with some number, say K. I make it KA, this KA. I make it KA. I multiply with K. Now the determinant of KA would be K to the power of n determinant A. This is a very, very important property. In case of when you multiply a matrix with a number K, that means, let me tell you, if with the above example, suppose I took the determinant of 2 to the 2 to the 2a, then I would have got 2 cube into 66, that is 8 into 66. That what is meant by this example, this one point. Now we will see, this is something very important. I'll again rewrite it later. Now we will see the sixth property. The sixth property say if any two rows or columns of a determinant are proportionate, then the value of the determinant is 0. That means, I mean to say, I will give you an example for the sixth one. Now see, for the sixth one, suppose I write the same type 5, 1, minus 1, and I write 2, 6, 0, and I write the multiple of the first row, that is 10, 2, minus 2. That is, I have multiplied this row 2 times. I've written here, since this is the multiple 2 times of this row is 2 times this row, therefore the answer is 0. Similarly, if I write, see, 1 4 3 3, wait, just a minute, 1 4 2 1 4 2 3 7 6 and 5 9 10. Now you can see this column is 2 times this column. So again the answer is 0 for the sixth property. Now for the seventh property, let us see. Yes, the seventh property, if an element, that is this one, if an element of any row or column of a determinant are added or subtract to the scalar times of the corresponding elements of any other row or column of a determinant, then the value of the determinant so obtained remains unchanged. That means, I'll make you an example, and with an example I'll make you understand this. Now for the seventh one, let us take this. Let us take this 5 1 minus 1 2 6 4 0 and 3 4 2. You got the determinant 66. What it is saying, if I multiply this the elements of this columns, let us say this column with some number say 2, and I add with this column. I said it is for row or it is for column, so let me multiply this with 2. That means I am multiplying and adding here. That means 1 2s are, this is 1 2s are 2, 2 plus 5 is 7. 6 2s are 12, and then 2 14, and then 2 fours are 8 and 3 is 11. 1, 6, 4 minus 1, 0, 2. That means I have multiplied this column with 2 and added to the first column. First column, but the answer still remains same. This is what means by the seventh property. Now let us come and understand certain more properties of determinant. Now see one thing. First property, you cannot write A plus B determinant as determinant A and determinant B. Not possible. This or minus, this is not possible. Second, A, B determinant can be written as A determinant and B determinant. Now Ka determinant is K to the power of N, A determinant where 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 A is n cross n matrix. N cross n matrix. This is the properties of determinant. With this we end this.